ladies and gentlemen, welcome to my class. Today we will be talking about probability of complement and union of events. You already know how to find the probability of simple events. However, in real life, some events are connected. Now, you will learn to find the probability of mutually exclusive and inclusive events. Let's try to explore the possibility diagrams and complement of an event. We have here a spin twice to get a prize. A supermarket promo requires a shopper to spin the wheel twice. If the wheel stops on the same price in both spins, the shopper wins the prize. What is the probability that the wheel stops on the same price in both spins? In other words, what is the probability that a shopper will win a prize? I think the probability of winning a prize is 1/5 because there are 5 equal sectors in the wheel. But you need to stop at the same sector twice. Now that's harder. What do you think? We know that the spinner is divided into 5 equal parts, and we assume that when spun, the spinner is equally likely to come to rest in any one of the 5 sectors. Now, to find the probability that the pointer will stop at the same number, we need to find the sample space, the possible outcomes, and the total possible outcomes, where A is the event that the spinner stops in the same sector in both spins. Let's try to use a tree diagram to show the possible outcomes. So we have here the 5 sectors of the wheel: 1,000 gift check, 500 cash, 2,000 groceries, 20% rebate, and free gift pack. Now we are going to spin it twice, so the results are here: 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and so on and so forth. And those who are encircled are the doubled results. That means you will win. So there are how many? 1, 2, 3, 4, 5. So another way of finding the outcomes in using the possibility diagram. So this is a tree diagram, and this is the possibility diagram. So we have here first spin and the second spin. So the encircled dots show the outcomes that the spinner stops on the same sector twice. In both methods, the possibility diagram and tree diagram, we see that the total possible outcomes is 25, and the favorable outcome is only 5. That means the doubles: 1, 1, 2, 2, 3, 3, 4, 4, and 5, 5. Hence, the probability that the spinner stops on the same sector twice is the probability of the favorable outcome over the possible outcomes, which is equal to 5 over the total outcomes, which is 25, and that is equal to 1/5. So a shopper has 20% chance of taking home a prize. Where did we get 20%? That is 1 divided by 5, that is 0.2, times 100%, that is 20%. Study the diagram and the possibility diagram. If the spinner does not stop at the same sectors in both spins, where does it stop? Clearly, let's assume that if B is the event that the spinner does not stop on the same sector, then its elements are the outcomes that are not in A. Hence, B is the complement of A. What I mean here is, if you will not get a double, where does it stop? So it could be 1, 2, 1, 3, 1, 4, and so on and so forth. So you can say that the event B is a complement of the event A. Thus, the probability of A plus the probability of B is equal to 1. Since probability of A is equal to 1/5, then probability of B is equal to 4/5, because when you add 1/5 plus 4/5, that is equal to 1, or that is equal to 80%. So the probability of A plus the probability of B equals 1/5 plus 4/5, which is equal to 1. This observation can be summarized as the complement of an event is the probability of not E is equal to 1 minus P probability of E, where E is the event. Like here, 1 minus the probability of A is 1/5. What is 1 minus 1/5? That is 4/5. Therefore, the probability of B is 4/5. Let's have example number 1. The spinner is divided into 5 equal parts. If it is spun twice, find the probability of the following. A. We have both spins stop on even numbers. Letter B, we have both spins stop on odd numbers. And letter C, one is odd and the other is even. Now, let's try to solve this one. Letter A. All possible outcomes for this experiment is shown a while ago, the possibility diagram. There are 25 outcomes here, right? 1, 1, 1, 2, 1, 3, 1, 4, and there are 25, all of them. The probability of both are even. We have 4/25. You can check the possibility diagram to check why it's 4 and why it is 25. So there are 4 which are even, and they are all 25, so 4/25. And letter B, both spin stops on odd number. Odd numbers, what are odd numbers? So 1, 3, and 5. So these are the only odd numbers in the spinner that we have here. So you're going to count those odd number results, so that is equal to 9/25. Again, you can rewind the video and try to check a possibility diagram in order to find really if there are 9 odd numbers when you span the spinner twice. So that is 9/25. And letter C, one is odd and the other is even. So an odd number, an even number, or even number or odd number, they're the same. So you will just count the results in the possibility diagram that I showed a while ago. There are 12 all in all over 25, so the probability of one is odd and other is even is 12/25. How about example number 2? Each spinner is divided into 4 equal sectors. The pointer in each spinner when spun is equally likely to rest in any one of the 4 sectors. The pointer in each spinner is spun once. Find the probability that the sum of both scores is as follows. A odd, we have B even, we have C at least 5, and D less than 5. So let's solve letter A. An efficient way of showing all outcomes is through a possibility diagram. This diagram shows a total of 16 outcomes. So when you spun the first spinner, so we will have 1, 2, 3, 4. In the second spinner, we have also 1, 2, 3, 4. So when you add 1 plus 1, that is 2, 1 plus 2, that is 3, 1 plus 3, that is 4, and so on and so forth. And there are 16 all total outcomes. So the total possible outcomes is 16. So let's try to solve letter A. Find the probability that the sum of both scores is odd number. So let A be the event that the sum is odd. In getting the, you will just look at the possibility diagram and count how many are odd numbers here. So we have 3, 3, 5, 5, 5, 5, 7, 7, and they are all 8. So 8 over 16, which is the possible outcomes, equals, reduced to the lowest term, that is equal to 1/2. So therefore, the probability that the sum of both scores is even is 1/2 or 50%. Let's have letter B. The probability that the sum of both scores is even. 1 minus the probability of A, which is 1/2. So what is 1 minus 1/2? That is also 1/2. Or you may refer to the possibility diagram. You will just count the number of outcomes which are even. So we have 2, 4, 4, 4, 6, 6, 6. So you will count all of those. So those are equal to 8 over 16, which is also equal to 1/2. Letter C. The sum of both scores is at least 5. So you will just count here in the possibility diagram the sum which is at least 5. What do you mean by at least 5? It could be 5, 6, 7, or 8. So you will count all of those from 5, 5, 5, 5, 6, 6, 6, 7, 7, and 8, 10 in all, so over the total possible outcomes, which is 16, so reduced to the lowest term, that is 5 over 8. You may check your answer by counting the sums that are at least 5 in the possibility diagram. Letter D, less than 5. When we say less than 5, so what are the sum which is less than 5? We have 4, 4, 4, 3, 3, and 2. This is also the complement of at least 5. Less than 5 is complement of at least 5. That means we will just subtract 1 minus letter C, which is 5 over 8. So what is 1 minus 5 over 8? That is 3 over 8. Or you will just count how many are the sum which is less than 5. So we have 1, 2, 3, 4, 5, 6. So 6 over 16, that is equal to 3 over 8. Let's try to explore the probability of the union of mutually exclusive events. Suppose we have here right to play first. So in a game of Scrabble, Cyril and Indira decide to let the die determine who gets to put the first word on the board for a change. Both players roll the die, and whoever gets the higher number plays first. Cyril rolls a 4. What is the probability that Indira gets to play first? So Indira must have get 5 or 6, right? In order for her to play first. We all know that there are 6 number in a dice, right? So 1, 2, 3, 4, 5, 6. So Indira should get 5 or 6. So that means the probability of Indira to play first is equal to 2, which is 5 or 6, over 6, which is the total number of the dice. So that is equal to 1/3. Right? So the probability that Indira will get to play first is 1/3. So this kind of event is called a compound event. A compound event consists of 2 or more simple events that are connected by the words and or. 2 events are mutually exclusive if both events cannot occur at the same time. These events have no common elements, like you cannot get a 5 or get a 6 at the same time, right? Example, in your school, in our classroom, selecting a female or a male. These 2 events are mutually exclusive because you cannot select a female which is a male, right? These events have no common elements. The probability of 2 mutually exclusive events is found by adding the probability of each event. Thus, in right to play first, we're going to add the probability of a die which shows a 5 and the probability of a die that shows a 6. So probability of a 5 or A plus probability of B, that is 1 over 6, because 5 there's only one 5 over 6 numbers, plus there's only one 6 over 6, that is 1 6 plus 1 6, that is equal to 2 6 or 1/3. So the same result is obtained a while ago. So this finding can be generalized as probability of mutually exclusive events. Probability of A or B is equal to the probability of A plus the probability of B, where A and B are mutually exclusive events. Example number 3. A card is drawn at random from a deck of cards. What is the probability of drawing a queen or a king? Let's try to identify first if it is mutually exclusive or not. A queen. Is there a queen which is a king? No. Therefore, this event is mutually exclusive. Thus, the probability of queen or king is equal to the probability of queen plus probability of king. How many queens are there in a deck of cards? There are 4, right? Also, there are 4 kings, and there are all 52 cards, so 4 over 52 plus 4 over 52, that is 8 over 52, or reduced to the lowest term, that is 2 over 13. So the probability of drawing a queen or a king is 2 over 13. Example number 4. A box contains 4 red balls, 5 green balls, and 3 blue balls. Helen draws 1 ball at random. What is the probability that the ball is either green or red? Green or red. Is there a green ball at the same time red ball? No. So this kind of events are mutually exclusive events. You will just add the probability of green and the probability of red. So we have here, how many are red balls? We have 4. And how many are the total balls? We have 12. Plus, how many are green balls? We have 5. Over the total balls, we have 12. So 4 over 12 plus 5 over 12, that is 9 over 12, or 3/4. So the probability of drawing a red ball or a green ball is 3/4. Example number 5. The probabilities of 3 contestants X, Y, Z of winning the grand prize is 1/5, 1/6, and 1/3 respectively. Assuming that only one contestant can win the grand prize, find the probability that either X or Y wins, or B, neither X nor Z wins. So here, since only one contestant can win, the events are mutually exclusive. So in solving letter A, either X or Y wins, so we will just add the probability of X wins and the probability of Y wins. The probability of X, we have 1/5, plus the probability of Y, 1/6. So what is 1/5 plus 1/6? You cannot add directly the two fractions, so you will get first the LCD. LCD is 30, so when you simplify that one, so 11 over 30. So the probability that either X or Y wins is 11 over 30. Let's go to letter B. Neither X nor Z wins. It's the complement of either X or Z wins. So we will solve first the complement of either X or Z wins. So the probability of X or Z wins is 1/5 plus Z wins, we have 1/3. What is 1/5 plus 1/3? That is 8/15. So that is either X or Z wins. What is neither X nor Z wins? So that's complement. So we'll just subtract 1 minus 8/15, which is equal to 7/15. So the probability of neither X nor Z wins is 7/15. Let's try to explore probability of the union of inclusive events. What's the difference between inclusive and mutually exclusive events? There are 30% chance of rain on Saturday and 70% chance of rain on Sunday. So there is 100% chance of rain this weekend. Well, there is 30% chance of rain on Saturday and 70% chance of rain on Sunday. The events are not mutually exclusive. It is possible that it might rain on both Saturday and Sunday. These events are said to be inclusive. When we say inclusive events, these are events that can happen at the same time. Unlike in mutually exclusive events, there is no common element like selecting a female or selecting a male. There is no female at the same time male. Inclusive means, another example for this, selecting a female or selecting a student with a curly hair. There could be a female who has a curly hair. So the two events are inclusive because there are common elements, or it can happen at the same time, right? So those events are called inclusive events. Let's try to check this next example, number 6. A die is rolled. What is the probability of getting an even number or a factor of 2? So let us say that A is the event when you get even number on a die. What are even numbers? 2, 4, 6. What are factors of 2? 1 and 2, right? So let's take this for example. So we have here, in rolling a die, get an even number. That's A. You get the Venn diagram there. A, so 2, 4, 6. And letter B, that's factor of 2. What are factors of 2? 1 and 2, right? They are common of the two events. We have 2. In solving, the probability of union B is equal to the probability of A plus the probability of B minus the probability of their intersection. So probability of A, which is getting an even number, plus the probability of factors of 2 minus the intersection. There is 2. So what is the probability of A that's getting an even number? So how many are even numbers? We have 2, 4, 6. So there are 3 over 6. What is 3 over 6? That is 1/2. Okay, that's 1/2. Plus, what is the probability of B, which is a factor of 2? We have numbers 1 and 2. There are 2. What is 2 over 6? That is 1/3, right? So 1/2 plus 1/3 minus the intersection of the two events. What is the intersection of the two events? The common, we have 2. There is common number which is 2. How many? Only 1. So 1 over, why is it 6? Because there are 6 numbers in a die, so 1 over 6. So 1/2 plus 1/3 minus 1/6, that is equal to 4 over 6 or 2/3.